Hello, everyone. This is Sean from IBM Consulting. Recently, I have access to 8 NVIDIA H100 GPU clusters. So that is a great resource and series power box. So I run some experiment on this popular open source model like from OpenAI GPT-OSS-20 billion and also 120 billion. Specifically, I use this open source Python library vLLM to do some performance testing and also do a accuracy test, use a large language model as a judge. So today I want to quickly show you the setup and some main concept to consider when you run or serve uh, large language model locally, and also to show you the experiment result. So to do this, I use VS Studio, VS Code, where here you can see I connect to my remote host where I have 8 H100 GPU. Each of them have, I think, 80 GB for the memory. And this remote server is using Red Hat Enterprise Linux to as a system. Then the code is not much. Essentially, after you install the vLLM library, you can just pick the model you want to serve. Here I use OpenAI GPT-OSS-20 billion. That can be 120 billion. Then the local host you set up, then you want to use 8 GPU to parallel. Um, then you have this D type to define the size of each large language model's weights or parameters. I will come to this later. This is change the size of the large language model. You have large data type will be larger the size, the smaller type will smaller the size impact the performance and the speed as well. This model length is like the context window the model can handle. I use this 32,000, which is should be sufficient for most of the use case. Then that's it. When you run this one, it will check if you already download the model. If not, it will download from the Hugging Face or can be used from your local saved model as well. Then it will serve. Um, then when it's running, so to get it running, there is some key concept I want to share. And also this, I learned that when I'm doing this, to run large language model or small language model locally, we all notice there is a number in the open source model. For example, this 20 billion or 450 billion or 8 billion, 3 billion. So that is the number of the parameters in this large language model. Consider that is a very complex mathematical formula. Each of that is just a ways, and we use that to do the calculation to get the next token probability. Which one with highest probability will be the next token generated from the large language model. Then two, we'll say hardware requirement or two main concept. One is how fast the GPU can do the calculations. And the second one is the memory, how large the memory has, like called the memory bandwidth, to parsing or host the all these parameters. Let's do the calculation first. For one H100 GPU, the compute power is like over 1,000 trillion floating point calculation. And in this model, we have 120 billion parameters. So you can see this 100 trillion compared to 120 billion is we have enough computer powers. But if we think about the memory bandwidth, we need GPU to host all these parameters to do the calculation. For 100 billion parameters, if we consider each parameter size is 2 bytes, can be 4 bytes or 1 byte, but if we find a balance between the accuracy and the model size, 2 bytes is kind of a good or common choice. So that will be 2 multiply 120 is 240, likely the gigabyte, the size of all the parameters. Then compared to 3 terabytes, you can see this could be the bottleneck for us to get faster speed. Of course, it's compared to the compute power, which is 1,000 trillion per second. So we will hit to the limitation for the memory before we get to the limitation for the compute power. So that's why we often heard the limitation is on the memory side, not on the compute side. So that is two essential concept. Okay, quickly assess how big model we can run with 40 GB memory GPU or 80 GB, or you have 8, how large you can run. Another case concept called KV cache. So this one is also cache, so it's also in the memory, and it's also very important for the performance. What it does is we know the large language model is generate token based on your input token or previous tokens. With KV cache is kind of store all the previous calculations. So when the new token come in, it just use that previous result instead of recompute every previous tokens before. So you can see this is very important for us to get good performance, and well, especially when we consider this more than one users, like multiple users uses at the same time. So we need this GPU to memory to store this KV cache for each users, since that is your context, your chat with these models. So KV cache and memory size and compute performance. That is three things to consider for the how large model you can support with your GPU, and memory is commonly the bottleneck we need to overcome. With that in mind, I will quickly show you how do I run the performance testing. So I use this also the vLLM library. It have more besides the server serving the model, it can run the benchmark. What it does is you can after you set up your server, the model or server is ready to accept request. This command is to um, do some pressure testing. For example, you can configure your concurrency. That is to configure how many users will access the server or request the server at the same time. And also you can provide your own testing data set. What I have here is like a RAG-like testing. Each prompt I gave the question, I gave the context. Also, this data set have the truth or the grunt answer or golden answer or from these questions. So after I have that, I run this with different concurrency. You can see here from 1 to 64, and also run this on 20 billion and 120 billion as well. So the conclusion based on this benchmark is I think is with 8 H100, we can provide 300 to 1,000 user organization with this Copilot chat-like experience. So we're more detail on this one is for the Copilot chat-like experience, I use this metrics called time to the first token. It's like when you see the first token come back. For Copilot, this is not official, but it's more like 2 seconds to 5 seconds. it can be more faster than your experience may be faster than this, but this is just like a benchmark. We can use that. Then we can see what we have here. There is a orange line is um, percentile 99 percentile will experience within 2 seconds. You see your first token response. It's roughly 50 for 20 billion and 40 for 120 billions. And also, let's assuming the peak concurrency is 5% or 15% of the headcount. So we got the number 300 to 1,000. So realistically, I think can support more if consider how we use Copilot or large language model is not like you continue non-stop typing and you will get response, reading the response, then ask question, follow-up questions. Then after I have this information, I want to see for the 20 billion models, smaller models, how smart it is. I think officially is I forgot, it's like GPT-4o mini or some model from official OpenAI benchmark. For this experiment, I kind of push it to a little bit further. I want to compare with GPT-5 mini and on this RAG user scenario. Same testing data I used before is like in the prompt, I gave the question, the context, and I know the dataset gave the truth. Then I use large language model as a judge, which is GPT-5, to evaluate on these three things. One is if the answer is supported by the context. Second, if the answer is accurately based on the ground truth. Third one, if the citation is accurately from the large language model response. For example, if we have this gold answer which is truth, then local is the 20 billion model, open answered by OpenAI is GPT-5 mini. Then this is charged from GPT-5. We'll check each metrics, and if all three is 1, then we know that is a pass. And here we have the final result. So the of course GPT-5 mini won, but not a lot. So the 20 billion, the pass rate is 75% out of the 100 test case, and the GPT-5 mini is 78%. So you can see it's only 3% difference. Consider 20 billion small size model, I think it's doing pretty decent work. And also, this is a local host. So that is the performance. We can see the small large language model host on the local on this RAG scenario can provide a reasonable or similar experience as a closed model. And the benefit will be more control on your data, and you own all this, you own your model, and potentially you can fine tune that for the future or for your domain specific use. Thank you for watching, and feel free to reach out if you have any questions or you have use case you want to explore more.